So my kids came here to... Yes, can you hear me now? Okay. To hear my talk, so I will say a couple of words to them in Hebrew, and then I will switch right back to English. אני מאוד מתרגשת להיות כאן, גם כי אף פעם לא דיברתי מול כל כך הרבה אנשים, אבל בעיקר כי בעלי והילדים שלי כאן. אז בעלי וובה, שהוא ראש צוות R&D ב-JFrog, לא כזה מפתיע שהגיע לכנס, אבל עדיין תודה רבה על כל העזרה. ומתן ועמיתי מתוקים, אתם עדיין לא יודעים אנגלית שוטפת, ועדיין לא יודעים מה זה קוברנטיס. אז עדיין. זה שבאתם לעודד אותי זה כיף מאוד, ובכלל לא מובן מאליו. אני הכנתי לכם כמה הפתעות במצגת, תחפשו אותם, הם יהיו בחלק הימני של השקפים, תסרקו אותם ותראו מה יש שם. Okay, so back to English. So my son Amitai is 9 years old, and my son Matan is 10 years old. They don't know yet what is Kubernetes, and they don't speak fluent English yet. So I have prepared QR codes for them to scan during this talk. So some of the slides will have QR codes that are on the right side of the slide, and that is for them to scan. If some of the adult audience gets bored with my session, you can also scan those QR codes that are on the right. So my husband told me that the key to a successful session is quoting Kelsey Hightower. Usage matures products faster than hype does. I definitely agree. One more quote just to be sure this session is a success. You haven't mastered a tool until you understand when it should not be used. Last quote for now. Smart people ask dumb questions. Luckily, Kelsey said nothing about dumb answers, so you're welcome to ask me questions later during the session break or on Slack. My name is Regina, and I am a huge GitOps fan. I'm also a cloud platform team lead in Bank Hapoalim. Since I was a little child, I was always the only female somewhere, the only girl in class, one of the few women lecturing in DevOps areas. And lately, I have also become one of the few female open source contributors. Combine that with the non-existing line to the ladies' restroom at this conference, and you will relate probably to what I'm saying. This is a shout out to all the ladies to participate as well. Me and my husband have 2 boys, so that makes me outnumbered again, this time in my own family. How many people came to this session to hear about a problem that happened to someone else? All right. Misconfiguration while working with Kustomize is what happened. I will tell you about what caused it, how we fixed it, what we learned from that, and how we improved our methodology as a result. In this session, we will be focusing on GitOps for cluster management, especially on managing Argo CD config with GitOps. What I will talk about today is from the perspective of cluster admin and from the operations perspective, but the insights and the methodology are relevant also for managing business applications configuration. Our GitOps manage desired state. We manage multiple OpenShift clusters. We have clusters with Argo CD that are managing other clusters. We use multiple tools or products per cluster, such as Prometheus, Grafana, Loki, VPA, Vertical Pod Autoscaler, Litmus. Some clusters have Crossplane installed, some have Argo CD installed, and many, many more. We also have multiple OpenShift operators per cluster. And we often have the same product that is configured differently per cluster. We manage a lot of OpenShift specific configuration, and we are dealing with frequent upgrading of the tools. Many tools that we use are basically plain Kubernetes manifests. They are not all Helm charts. You can understand that we manage a lot of stuff, a lot of tools, and a lot of products. And when we talk about GitOps, the repo structure is key. So let's see what was our initial Git repo structure and how it evolved. You see that there are multiple Argo CD instances. And each manages multiple clusters, much more than the two in this chart. So at the beginning, we duplicated that architecture to our Git repos. And you can see that basically we have one Git repo which is for the Argo CD configuration, and then another Git repo for the desired state of the clusters that we managed. Each such cluster results in a separate branch. It's used to result in a separate branch in the repository, and also each cluster where Argo CD is installed, which is called the control plane, also used to live in a separate branch in the central repo. So basically, we had a many repo, many branch architecture, and we had a lot of configuration duplication. And when people needed to add new tool or new products, they didn't know where to commit it to. This structure was a mess. And so we decided to move to monorepo, monobranch in order to avoid the duplication, and so that there is one place to look at to get the picture of the overall desired state. The branch per cluster or per environment is an anti-pattern. Don't do that. Never, ever don't do that. You can read more about this at Kostis Kapeloni's blog. This QR code is for the adults in the audience. Feel free to scan it and to read through it afterwards. So now we have a monorepo, monobranch for all the clusters configuration. But you hopefully remember that we need to manage many products that come as plain manifests, and we are focused on configured the same product on many clusters differently. One option was to do that with Helm. How many people use Helm? All right. Let's recap what Helm is. Okay. Hopefully my kids scanned it. Yes, good. Helm is a Kubernetes package manager. It is a CNCF graduated project, which means that it is considered to be stable, widely adopted, and production ready. It automates the software packages lifecycle. That means installing, upgrading, removing, etc. It uses a template engine. And what it does, it enables us to share and reuse software packages that are called Helm charts. The chart consists of a template directory, a values YAML file with the parameters to be used with those templates, and a chart YAML file, which describes the chart. And the templates are basically YAML files with Go, template, and template functions. Another option for configuring the same product on multiple clusters differently, and in some in an identical way, was to use Kustomize. How many of you have heard about Kustomize or use it? Okay. There are people who love Kustomize. There are people who hate Kustomize. My husband asked me, why is Kustomize misspelled with a K? So let's quickly cover what Kustomize is and what problem does it solve. Kustomize is a Kubernetes native configuration management, and this is why it is spelled with a K. There is a big community around Kustomize, and it is even bundled into kubectl. It uses a declarative approach to Kubernetes configuration. It enables us updating configuration without forking by traversing a Kubernetes manifest to add, remove, or update configuration. It uses layering over base settings to selectively override default settings without changing original files and avoids configuration duplication. The common configuration in Kustomize is referred to as base, and the overrides of this common configuration are referred to as overlays. Overlays are patches to base manifests or additional manifests. The final Kubernetes manifests are produced upon running Kustomize build. This command processes the base and overlay files, which are basically fragments of configuration, and produces the final plain Kubernetes manifests. Now, why we chose Kustomize? You remember that we manage configuration of many products, of many OpenShift operators. We need to be able to upgrade those products frequently, as we do not want to fall behind with old versions. We also need to add OpenShift-specific configuration to many of those products. So the manifest change in those products is externally driven and frequent, as opposed to manifests of self-developed business applications, the change in which is internally driven. We're focused on configuring the same tool on multiple clusters differently. We are not focused on versioned software artifacts. What we need is a flexible configuration without changing original manifests, because if we change the original manifests, then upgrades to the product would get us to merge hell and would be slow and error-prone. So keeping the original product manifests separate and untouched is crucial. Kustomize provides clear separation between what is common and what is overriding, so the original manifests of the product naturally fit into Kustomize base, and then our configuration changes naturally fit into Kustomize overlays. So wrapping those tools in Helm chart seemed like an overhead. If we chose Helm, we would need to write the Helm templates ourselves for each such product or configuration. Now, you remember that Helm template is a combination of Kubernetes manifest fragments and Go template code. So when such tool has a changed version and new manifests, the merge with our own self-grown Helm chart would be time-consuming, because with Helm, we wouldn't be able to avoid changing the original manifests. The technology we use should be always working for us and not the other way around. And in this case of third-party products and tools that come as plain manifests, writing our own Helm chart for each such tool seemed like working for the technology. However, using Kustomize for that looked like the technology is working for us. Argo CD. We started with Argo CD long before there was a stable Helm chart. And migrating to Helm chart didn't seem worth the effort until some point in time, but we're constantly looking at it and might migrate to Argo CD Helm chart in the future. How we manage Argo CD configuration. So now that we have covered why we chose Kustomize, let's see how we manage this. We have Argo CDs on different clusters. Our Argo CD configuration is self-managed by Argo CD. We managed Argo CD config maps with Customize. And there is a part of the Argo CD config map that is common to all the Argo CDs. And there are parts that are relevant for only specific Argo CDs, and they are different. So the config map that is common to all Argo CDs is in base, and the config map parts that are specific to each Argo CD are in overlays. The overlays are basically patches to the main Argo CD config map. This is a visualization of the repo structure. Oh, I want to show it to you on the screen just a second. OK, right. So this is the shared part. And those are the specific parts that override the shared one using patch. Control plane clusters are basically the clusters where Argo CD is installed. This is Argo CD config map part in Customize base. We use OpenShift routes, and Argo CD needs to be instructed about some route fields to be ignored during diffing. The reason is that the route host field is automatically populated by OpenShift at runtime. But those details are not significant. What is important is that this ignore differences section is responsible for the routes to be displayed as synced in Argo CD. A spoiler, the resource customization section is a multi-line value. It is important for later. Right. And this is the specific part. The Argo CD URL is unique to each Argo CD, and so is the DEX config. So this is the overlay Argo CD config map part. Now, this file instructs Customize to patch the base manifest with the contents of the overlay manifest using strategic merge. There are also other patch strategies that can be used. Now that you have all the background details, I will tell you what happened on November 13. November 13 is the World Kindness Day. What better day is there to break stuff in production and in other environments? So what happened that day? We received a requirement to implement an Argo CD custom health check for the ingress object. That requirement was relevant for a particular Argo CD. So the implementation was to add a custom health check to the overlay Argo CD config map. Let's look at the implementation. As you can see, yes, today. The resource customization section was added to the overlay with a health section for ingress. Now, let's look at the base Argo CD config map again. The ones who are experienced with Customize and were not defeated by lunch can probably spot the problem. The others would have to stay in suspense for a little while. So those are the tests that are performed before merging this change. I ran Customize build, and I verified that the word ingress was there. I did a kubectl dry run. I did an Argo CD dry run. I also made an actual run on a test cluster. All those tests, oops. All those tests were successful, and so I confidently clicked merge. After the merge, I verified that the ingress resource now looked healthy, and so the task was done. This is what happened 5 minutes later. Also 5 minutes later, we had a gazillion tickets opened. The CD of the business apps was failing. Most of the apps in Argo CD were out of sync. All the route resources in Argo CD were out of sync. Now, you'll remember that we now have a monorepo. So the first thing we do when we troubleshoot a problem is looking at the commit history. So I looked at the commit history, and surprisingly, the last commit was mine. Fixing the problem with monorepo is as easy as just reverting the commit. Now we will see what the problem was, what impact did it have, and what did I learn from that. This slide is for the ones who were in suspense until now. On the left, there is the expected final Argo CD manifest, and on the right is the actual final Argo CD manifest. As you can see, the route ignore different section is gone, but I didn't delete this section. So what happened? Well, the problem was the multi-line YAML that got entirely replaced by patching the base with what was in the overlay. Now let's see what impact did this problem have. The actual application deployment was successful, but the Argo CD status was out of sync. The CD pipeline commits the manifests, and then it waits for Argo CD to become synced, meaning this is synchronous operation. And that sync state was never reached. So the CD pipeline overall status was failed. Lesson learned number 1, overlaying file contents. I'm talking about having a part of a file in a customized base and then a part of the file in overlays, as opposed to having a copy of the whole file in overlays. It requires using patch, which is sometimes non-trivial. The most common use case probably is the deployment image overlay. So the question is whether other use cases are a best practice or a bad practice. The pros is that it eliminates duplication and it eliminates the I changed in one place but I forgot to change in the other place problem. The cons is that the impact of an overlay change is not obvious. The conclusion is use with care. Lesson number 2, patch and multi-line YAML. Multi-line value can be a YAML structure itself, but the multi-line value is a string. It is not a map. And so the so-called keys in the multi-line value are not real keys. So patching such a key in a multi-line value will result in the entire multi-line value being replaced, just like what happened to me. The conclusion is if multi-line values should be patched, consider getting the file out of base and keeping it in overlays in its entirety, or just use Helm. Lesson number 3. So the goal is to understand how a change in the overlay impacts the overall configuration. When I ran kubectl dry run and Argo CD dry run, I make sure that my change is valid from both Kubernetes and Argo CD point of view. But this is not enough. The missing part of the puzzle is the diff between the final new and the final existing configuration. This is not a diff in the customized file that I have changed. This is a diff in the final Kubernetes manifests. I will explain how we added this missing part soon. Had I seen this diff in addition to the diff of the file that I have changed, the problem would have probably not happened, and I would have been telling you another story today or just going to the beach instead. Lesson learned number 4, Git repo protection. The monorepo. So the GitOps desired state of all the clusters we manage is in this repo, and this includes monitoring tools, cluster configurations, storage operators configurations, and many, many more. Business apps GitOps desired state are managed separately, and they are out of scope for this session. Our monorepo is mostly customized based. A change can affect a production cluster. A change can affect multiple clusters at once. Having a monorepo is very convenient for cluster configuration because it enables us using tools like Customize to efficiently manage what is common and what is different among the clusters. Changes can be quickly introduced to multiple clusters at once, and operations can be lightning fast. However, breaking multiple clusters at once can be lightning fast as well. With great power comes great responsibility, so this repo must be protected well. So we realized that we need merge request approval. Merge request is GitLab terminology. We use GitLab. It's basically the same thing as GitHub pull request. We also realized that we need an automated validation and pre-testing of configuration changes. Now, merge request approvals and automatic tests sound familiar. Right? This is what people do for business applications, development, and CI. Well, managing Kubernetes infrastructure and operations has to follow the same path, maybe even more strictly. Especially in a world of Kubernetes is a control plane for everything, because then you end up managing not only the cluster as the cluster, but many other remote resources as well. The same concepts of working with GitLab, GitHub issues, merge requests, branch methodology, and CI tests apply here as well. Just like our code needs to be tested properly and sometimes reviewed, our configuration also needs to be tested thoroughly and sometimes reviewed. This is the last quote of Kelsey Hightower, I promise. Automation is the serialization of understanding. Let's take a look at how we serialize the insights from that incident with regard to Git repo protection, combined with understanding the effect of a change in a customized configuration. Here are the steps in our pipeline. kubectl dry run, Argo CD dry run. Now changes in base require an approval before merge. Changes in control plane cluster overlays also require an approval before merge, and so do changes in critical cluster overlays. Other changes are auto-approved as they are considered to be non-critical. Regarding the merge request approvals, they will never, ever replace automatic tests. But having a review from a colleague is a great way to spot problems otherwise overlooked. Unfortunately, waiting for a review is also a great way to slow down or even block operations. So we chose something in the middle. Wide scope changes like touching customized base and changes to critical clusters require a second eye, while changes on a playground cluster can happen without waiting for anyone and can be just merged. This is an example of a critical cluster change merge request. You can see the comment. I hope you can see the comment. Yes. That was automatically added by the merge request pipeline, saying that, oh my God, 2 more minutes? Okay. Okay, sorry, so we're nearly done, but looks like the time is run out. Thank you very much. If there are additional questions, I will be happy to ask them either on Slack or on LinkedIn. Thank you so much.